Hello everyone, welcome back to our AI engineering playlist of CodeTav management. So far we have covered three important topics. So first we understood like what AI engineering is. Second topic we have covered like the Python that is actually useful for AI engineers. The third topic we have learned the mathematics behind AI, including like vectors, matrices, probability, statistics, and gradient descent. And now we are entering one of the most exciting topics, machine learning. So, machine learning is the technology that allows computers to learn from data instead of being explicitly programmed. So, when you use the Netflix, so you see like Netflix recommendations. When you use Amazon, so Amazon product suggestions, Google search, YouTube recommendations, or some spam email detections. So machine learning is working behind these scenes. So by the end of this video, you will understand how machine learning works, the different types of machine learning, how models are trained, how they are evaluated, and how machine learning fits into modern AI system. So in today's session, we will cover everything a beginner needs to know about machine learning. Like we will start with the definition of machine learning, then we will understand why machine learning became necessary and why traditional programming is not enough for many modern problems. After that, we will learn the machine learning workflow, explore supervised, unsupervised, and reinforcement learning. We will understand the features and levels. We will discuss the training and testing datasets. We will learn about overfitting and underfitting. We will understand evaluation matrices like accuracy, precision, recall, F1 score, and finally build our first machine learning model that maybe in the next lecture. But today, like we will understand these concepts. So this session is designed to give you a complete foundation before we dive into algorithm in the next topic. Okay, so first of all, we will know what is machine learning. So let's begin with the most fundamental question. What is machine learning? So machine learning is a branch of artificial intelligence where computers learn the patterns from data itself instead of following manually written rules. So just if you want to compare this machine learning with the traditional programming, so basically in traditional programming, we provide the input and write all the rules ourselves, right? So the computer simply executes those rules to produce an output. For example, like if we want to calculate tax, we manually write all the tax rules into the program. However, machine learning works differently. Instead of giving the rules, we provide the input data along with the expected output. And the algorithm studies the relationship between the input and output. Okay. And finally, it learns the rules automatically. So this learned relationship is called as the model. So once the model is trained, it can make predictions on new unseen data. Okay. Now, why machine learning? Like, why did machine learning become so popular? Because many real world problems cannot be solved using fixed rules. Like, take email spam detection as an example. So, can we write rules for every spam email? No. So, spammers constantly change their content. Similarly, think about face recognition. So, every face is different. So, like lighting conditions change, camera angles change, expressions change, right? So, writing rules for every possibility is impossible. So, instead, we train a machine learning model using thousands or millions of examples. So, the model learns the patterns and becomes capable of recognizing new cases. So, this is why companies like Google, Amazon, Netflix, Meta, Tesla, OpenAI, they rely heavily on machine learning. Okay. Now, AI versus ML versus deep learning and generative AI as well. So many beginners just confuse these terms. So let's understand the hierarchy. So artificial intelligence is the broad field that aims to create intelligent systems. Machine learning is a subset of artificial intelligence. Instead of writing rules manually, systems learn from the data, what we have discussed already. And deep learning is a subset of machine learning that basically uses neural networks with multiple layers. And finally, generative AI is built on advanced deep learning models and can generate text, images, videos, and code. So, inside this generative AI, you can see one another part, large language models, and inside that, chat GPT. That is one example. So, I have given you the diagram as well. Like, think of it like nested circles. So, AI contains machine learning contains deep learning, deep learning powers generative AI. And inside that, large language model is also a part of generative AI. Now, every machine learning project follows a structured workflow. The first step is identifying the business problem. Next, we collect the relevant data. After collecting data, we clean and pre-process it. Then we train the machine learning model. After training, we evaluate its performance. If the model performs well, we deploy it into production. And finally, we continuously monitor the model because data changes over time. So this complete life cycle is followed in almost every production machine learning project. So let's understand machine learning using simple example, house price prediction example. So suppose we want to predict house prices. So we collect historical data containing information like area, number of bedrooms, number of bathrooms, and location. So these input values are called as features. The house price is called the level or target. So the machine learning algorithm studies thousands of examples and learns how these features influence the price. So later, when a new house is given, the model predicts its expected price. Now, the data types. Like machine learning works with different types of data. Structured data is organized in rows and columns. Like it includes like Excel sheets, CSV files, SQL databases, and relational databases. And unstructured data does not have a predefined format. Examples like images, videos, audio recordings, emails, PDFs, any social media posts. So modern AI systems often combine both structured and unstructured data. Now, understanding features and levels is extremely important. Like features are the input variables used by the model, like age, salary, years of experience, temperature, or house size. And labels are the outputs we want the model to predict, like salary prediction, house price prediction, spam detection, fraud detection, disease prediction. Okay, that are the labels. So label is the target and features is our input. So think of features as the questions and labels as the answers the model like learns from. Okay. Now training versus testing. So we never train and test on the same data. Why? Because we want to know whether the model can generalize. Typically 80% of the data is used for training and 20% is reserved for testing. 80-20 ratio. Train test split when we do in our projects. So 80-20 split we do, train test split. So training data helps the model learn. Testing data checks whether the model can make accurate predictions on unseen data. So this prevents false confidence. Now, types of machine learning we will know. So there are mainly three types of machine learning. One is supervised, that basically uses labeled data. Unsupervised learning uses unlabeled data. Reinforcement learning that learns through rewards and punishments. So we will now explore each one in detail. So first of all, supervised learning. So in supervised learning, every training example contains both input and correct output. So the model learns the relationship between this input and output, and then it will able to predict later. So the model learns the relationship between them. So common examples like spam detection, disease prediction, customer churn prediction, house price prediction. So supervised learning is one of the most widely used machine learning techniques in industry. Regression. Regression is used when the output is a continuous value, like predicting salary, stock prices, rainfall, or house prices. So the prediction can be any numerical value. Regression algorithms actually try to minimize the prediction error. Okay, that's the concept for the regression. Next, we have the classification. So classification predicts categories instead of numbers, like spam versus not spam, fraud versus not fraud, cancer versus not cancer. So the output belongs to predefined classes. Many real world business problems are classification problems actually. Next, we will learn about unsupervised learning. So in unsupervised learning, the data set has no labels. The algorithm basically discovers the hidden patterns automatically. So one common application is customer segmentation. So like e-commerce company may automatically group customers based on shopping behavior. Okay. Or like if you will give a bunch of fruit images, then through the unsupervised learning it can segregate what is apple, which one is guava, which one is mango, like that. Next is clustering. So clustering basically divides similar data into groups. So customers with similar buying behavior form one cluster. So high value customers may form another. So companies use clustering for marketing, recommendation, fraud detection, and customer analytics purpose. Now dimensionality reduction. Sometimes datasets contain hundreds or thousands of features. Not all of them are useful. So dimensionality reduction removes the unnecessary features while preserving the important information. So this makes the models faster, simpler, and often more accurate. Next, we have the reinforcement learning. So in reinforcement learning, an agent interacts with an environment. So every action receives either a reward or penalty. Like the goal is to maximize like long-term rewards. That's the main purpose of reinforcement learnings. Like AlphaGo, self-driving cars, robotics, any game playing AI. Those are the example of reinforcement learning. Like you can think like that. Initially, when a child start to work, okay, so the child will try to work and the child may fail. And in that way, repetitive trial and error, the child will learn how to keep the balance. So reinforcement learning is also like that. It will interact with the environment and eventually it will learn. And when it will learn, then it will be our maximize long-term profits or rewards. The next one is how models learn. So training is an iterative process. So the model first makes a prediction. It compares the prediction with the actual answer. The error is calculated using a loss function. The model then updates its internal parameters to reduce the error, and this cycle repeats many times until performance improves. So predictions, then through loss function, the error will be calculated, and then it will update to reduce the error, and finally it will repeat the process until good performance or better performance. Next is loss functions. So a loss function measures how wrong the model's prediction is. Large error means high loss, small error means low loss. So the objective during training is to minimize the loss. So like different problems use different loss functions. Next is optimization. So optimization tells the model how to reduce the loss. So the most common optimization algorithm is gradient descent. So it adjusts models parameters step by step until the model reaches the minimum possible error. Okay, so concepts like learning rate, epochs, iterations, those are also important during the training. Now epoch versus batch versus iteration. So an epoch means the model has seen the entire training dataset once. Batch means it's a smaller subset of the training data. And iteration means one parameter update after processing one batch. So understanding this concept is essential for deep learning. Next is overfitting versus underfitting. So overfitting happens when model memorizes the training data instead of learning general patterns. So it performs extremely well on training data, but poorly on the new data. So it will not able to learn about the general patterns. It will just memorize the models, like memorize the training data. Okay. So with data we have trained the model. With that data, it will give extremely well result. But whenever we will provide any unknown data, then it will give poor performance. So this is a common problem in machine learning. And underfitting occurs when the model is too simple, like it fails to capture important patterns in the data. As a result, it performs poorly on both training and testing datasets. And then is good fit. So good fit means like a good model finds the right balance, like it learns meaningful patterns without memorizing the training data. So this allows it to generalize well when unseen data is there. Next is bias versus variance. So high bias usually causes underfitting, and high variance usually causes overfitting. So the goal is to find the right balance between the bias and variance. Next is evaluation matrices. Through like this accuracy, precision, recall, F1 score, those are the evaluation matrices through how we will get to know what is the accuracy of the model. But first of all, we will learn about confusion matrix. So the confusion matrix helps us evaluate classification models. It contains four values: true positive, false positive, true negative, false negative. So many evaluation matrices are calculated from these values only. Next is accuracy. So accuracy measures the percentage of correct predictions. So it is easy to understand, but can be misleading for imbalanced datasets. Next one is precision. So precision answers this question, like out of all predicted uh, positive cases, how many were actually positive? Like precision is very important when fraud detection is there. Now recall. So recall basically answers another important question. Like out of all actual positive cases, how many did the model correctly identify? So recall is critical in healthcare because missing a disease can have serious consequences, right? So we need to understand like how many cases did the model correctly identify? That is the actual recall. Next is F1 score. So the F1 score basically combines the precision and recall into a single metric. So it is very much useful when classes are imbalanced. So machine learning basically powers almost every major technology company. Like Netflix recommends movies, Amazon suggests products, Google ranks search results, Tesla supports autonomous drivings, Spotify recommends music, LinkedIn recommends job, OpenAI build intelligent language models. So machine learning is everywhere. Now machine learning in AI engineering. So machine learning is just one component of a complete AI engineering system. So the flow typically looks like data, then machine learning model, then LLM, then RAG, AI agents, production deployment. So as AI engineer, our responsibility is not only to train models, but also to integrate them into reliable, scalable applications. So as a summary, like just recap what we have learned today. So we explored what machine learning is, it is matters, like the complete machine learning life cycle, supervised, unsupervised reinforcement learnings, features, levels, training, testing, overfitting, underfitting, good fit. We have learned about evaluation matrices and where machine learning fits in AI engineering. So in the next video, we will dive into machine learning algorithms where we will study algorithms such as linear regression, logistic regression, decision trees, random forest, k nearest neighbors, support vector machines, and naive Bayes, along with some practical examples as well. Okay, so see you in the next lecture. And don't forget to like and share and subscribe. It will motivate me to give more such videos. Okay, I think it will be helpful for you as well.